So make it bigger. All right. Now we are in our 5th week already. So meaning to say 2 more weeks left for my part, okay, before I hand over to others. All right. So we have talked about network diagram, and the network diagram that we focus in our class is basically AOA diagram and then AON diagram. So we already finished talking about or giving the example of how to draw AOA diagram and then putting all the values with regard to early start, early finish, late start, late finish, and then total float and free float, how to determine the critical path, etc. for AOA diagram. Now we want to focus on AON diagram, and subsequently the enhanced version of AON is called PDM diagram. Okay, so we will cover AON, and then after this we will go into PDM diagram, which is more complicated diagram, and then including all the calculations. So that is the syllabus. Okay, before we go into the detail, let's introduce about AON diagram. So critical path method. So critical path method we already mentioned is the calculation method, okay, or mathematical method in order for us to figure out, for instance, the critical activities, and then subsequently the what we call the values for early start, early finish, and whatnot. And remember, CPM is the calculation method. We can use either AOA diagram or AON or PDM diagram especially in order to show all values inside the diagram. AOA diagram was being developed way back in 1950s by US Navies. You can read the history of those things. I'm not going to go into the detail, okay? And AOA diagram basically use arrow and nodes in order to indicate the activities. So the use of arrow is very important because the arrow itself indicate an activities. Whereas AON diagram was being developed way back in 1960s, okay? Later on, it was the enhanced version being called PDM diagram. PDM diagram was founded way back in 1964 or being used in IBM computer programming back then. The special thing about PDM is basically instead of using the original finish to start relationship, it introduced, you see, extra relationship plus the leg could be positive or negative. So this is what make the PDM diagram special compared to just AON diagram. Okay, so that's why in this slide it mentioned PDM diagram as an enhanced version of AON diagram, because previously AON diagram was being developed based on finish to start relationship. Similarly, AOA diagram, even until now, only use this type of relationship. So that's why AOA diagram is not that popular nowadays due to the fact that it limits the relationship that we can use in such a way. If we still want a different relationship, and then the diagram would be very complex because we need to split up activity and etc. Okay. Element of critical path. When we want to construct this diagram using critical path concept, we must list all the activities. So we already mentioned how do we get the list of activity is from our WBS exercise. Okay, if you go through the WBS concept, then basically you would be able to generate all the activities, including the dependency. Dependency is basically the relationship, the logical relationship between an activities. The duration is very important. Otherwise, we are not going to be able to come out with what is the overall project duration. Without the activity duration, okay, we just simply cannot get the overall project duration. So how do we calculate activity duration? Again, from the concept of productivity rate or output capacity, or sometimes people say labor constant, um, machinery, productivity rate, etc., etc. Those are the concept. Okay, CPM, critical path method, calculate the longest path. Okay, the longest path of in any network diagram, because in any network diagram there could be many paths, many paths. So when we talk about network, it should have many paths, and among the paths, they could be one or two or it could be multiple. Remember one thing, critical path is not single. It could be multiple critical paths. But in our example, normally, or even in our exam for learning purposes, we do not have so many paths actually, because we only give limited number of activities. Otherwise, you will take forever in order to solve the network diagram. So that's why at the end of the day, you will see as if critical path is only one. But in reality, it might not be one. It can be multiple critical paths. That could be the logic. Okay. But anyway, the critical path, whatever it is, either it is one or two or three or multiple, indicate the longest path. Let's say there could be 10 paths. Among those paths, two paths basically have the longest. The longest meaning to say they could be similar in terms of values, and they are being considered as the longest path, and it indicate the project duration. And automatically, activities are in the critical path will be considered as critical activities. Okay, whereas activity which are not on the critical path, they are being considered as non-critical. Why? Basically, we want to know whether they are critical or non-critical activities, because it has something to do with regard with the delay. Delay mean whether we can basically have extra time, or we can play around. We can play around with the timing or the completion of certain activities. So for critical activities, so that activity we can consider that it basically have no free time. Here, total float basically zero, equivalent to zero. Whereas for non-critical activity, it indicate that activity basically do have some free time, or we can delay that activity within the allowable, what we call total float values. Okay, if there is a total float values for that particular activity, meaning to say that activity are considered as non-critical, they can be delayed a little bit according to whatever the total float values. Whereas the critical activity, the total float value must be equivalent to zero. Okay, so that's why we wanted to know all this value, because we will use that concept later on during resource management, which I might not cover, okay, because it is on the second half of the syllabus anyway. Okay, another issue is prioritize activities. Why basically we wanted to use critical path method? Because once we indicate those activities are critical and non-critical, then we can prioritize. In terms of what? In terms of resource assignment. We want to assign resource. Resource could be equivalent to people, equipment, or even money can be considered as resource. But the most critical thing is basically people and equipment. Where does the money come from? Is basically when you pay people, when you pay the machinery, that is basically when money will be generated, okay, automatically. So in resource assignment, we want to prioritize. Let's say there are two activities running almost at the same time. Let's say C and E running at the same time, and they both basically require the same resources. And now we are having difficulties. Where should we prioritize? So if E is the critical activity, critical, then basically, and C basically do have some extra time that we can delay a little bit in terms of starting and ending, then that resources is basically to be put first on E. Then only later on, they will come back to complete C. That is the concept of prioritize. Okay, when we are able to prioritize, perhaps in such a way that we could be able to lower down the cost of resources instead of renting another machinery, because we need that thing in C or in other activities. Why don't we just simply use whatever resources that we have, but then as a matter of either we want to delay a little bit or what? That is the concept of prioritizing. Enter shorter duration original plan. Okay, in this situation, sometime you know that your project is running late. Okay, your project is running late. Let's say the COVID has struck the nation, and then your activity has been put off due to the government order and whatnot, and you realize that after the COVID is gone, the remaining time is very short. Okay, the remaining time within the contract period is very short. So, example, let's say one activity, activity G, for instance, you put the original duration as 10 days, but that 10 days is based on the original schedule. Now, you basically don't have that 10 days. You have to complete that within maybe 4 days instead of 10 days. So, meaning to say, you must increase your resources. You can increase resources, or you can cut down on holidays. You are the one that plan, we do not work during the weekend. We start work at 5, for instance. Now you have to utilize as many ways as possible. Some of the ways, for instance, you cut off your calendar. Okay, you work extra time, you increase the number of machinery, the number of people, and you basically delete the calendars. Okay, delete the calendars. You start relationship. Okay, or to overlap some of the activities. Well, the simplest way to do scheduling is using finish to start relationship. Then you don't have any headache. It's very simple. You can use just simply AOA diagram, because AOA diagram is just using finish to start relationship. But then the duration to complete the project will take longer. Why don't basically you overlap certain activities? Don't wait for activity A to complete to start activity B. This is what we call overlapping. Or you can start two activities concurrently. But you have to remember, when you start two activities concurrently, meaning to say those activity cannot use the same resources. They must be, you must have some kind of team A and team B. Well, what to do? Because now you are running late of time, you cannot just simply use the same resources for the both two activity. Now you had to split, okay? Activity A and B, doing concurrently or some overlapping matters, and then so that you can cut short on the overall project completion. Instead of complete on this day and then basically you reduce the remaining activities. Divide long activities into several shorter activities. Sometimes you indicate an activity by a very long duration. Then the following activity will basically wait for the completion of this activity in order to connect from to connect the relationship. Okay, what if that activity, instead of taking this long period of time, it will take longer, then basically this activity have to wait longer. So we can split activity into several activities so that this is like say A, B. So this activity can be, for instance, done immediately, or when activity A are partially complete, then basically we can start activity B. Okay, there are some situations, for instance, cut and fill activities with regard to backfilling, with regard to slope, etc., etc., because that area is very big. You don't have to wait for the whole area to complete. Then basically you will do some kind of excavation on a certain point. Okay, you can just simply start doing your excavation on certain point when area A already completed, part of the area A. That is the example. Benefit of critical path: allow continuous monitoring to track critical activities, and basically the issue of dealing with delays. Okay, when we know in a network diagram, they are, for instance, we know the impact of delay to certain activities with regard to the predecessor and successor of activities, then basically we can come up with a strategy how to basically to mitigate the issues. Project management software, I already mentioned. Nowadays, the best way to put activity is basically into a software, either Microsoft Project or Primavera. Why we suggested these two? Because they are widely used, especially in Malaysia or basically worldwide. If you want to learn, so basically you learn these two software, that will be sufficient enough. Microsoft Project and Primavera, in comparison, there are differences in terms of the application. Okay, the application. Microsoft Project is meant for complex industries such as construction and oil and gas, whereas Microsoft Project can be utilized on multiple industry or different various industry. Okay, and then my Primavera is always normally 10 times higher in terms of cost. So you can imagine if certain, even for instance, handphone costs much more compared to basic handphone. So there must be something inside those handphone. Could be certain features that basic handphone basically doesn't require. Okay, so it depends on where you want to use. For me, if you learn Microsoft Project, that will be sufficient enough. Okay, we are going to use a lot of Microsoft Project, especially for second half of the class. Example will be done in Microsoft Project. So make sure you do have Microsoft Project installed in your computer. Later on, you are going to follow the some of the work example that we are going to show. Okay, now introduction of the PDM diagram dependency or logical relationship. Remember, AOA diagram, AON only basically use this one. AOA, AON basically use this type of relationship. But then the extra relationship is a unique relationship basically in a PDM diagram. Okay, now let's revise. We already mentioned this thing in our previous slide anyway. Okay, let's say finish to start relationship, FS. How do you draw? Okay, just remember, in a bar chart, the left side of the bar indicates start. The right side of the bar indicate finish. Even in the what we call bar chart. In the AON diagram or PDM diagram, let's say this is activity, we do have all kind of compartment inside here. The left side of the box, this is the left side, indicate start, and then the right side indicate this is right side, indicate finish. So when you draw an arrow coming from the right side, this is finish, and going into the other box from the left side, so this indicates start. So this, you see, this arrow indicate finish to start relationship. Okay, the way you draw those arrow in AON or PDM diagram do indicate the type of relationship. You don't have to put a note such as FS and whatnot from the drawing itself. But remember, when we talk about software, MS Project and Primavera being expensive software do draw according to the type of relationship very nicely. Unlike Microsoft Project. Microsoft Project, for the time being, for the current version that we have until 2019, still in terms of network diagram, they simply draw, all the drawing is based on finish to start relationship drawing. But inside those, what we call the type of relationship, do indicate the right relationship, but in terms of the drawing, maybe the graphic is not that advanced for the time being. They might not be able to draw according to what we want. But if we draw manually, you should be able to draw according to the type of relationship. Okay, let's say clustering. And the relationship between activity should indicate the logic relationship. We do not do painting first and then later on plastering. No. We do plastering first on a wall. Then after plastering complete, then only we do the painting. If, for instance, the wall is very big, okay, the wall is very big, you do the plastering, but then of course, while waiting for the whole wall to complete, certain part of the wall is already dry up. Then immediately you will do painting. You do not do the painting on the last portion of the wall anyway, because it is still wet. You will do at the first corner where you start painting on the first place anyway. Okay, that is the logical relationship. Okay, then start to start relationship, SS relationship. When you have two activities, let's say activity cutting, we consider as a starting activity A, this could be B. So in this situation, there is an error in terms of wrong way of drawing. By the right way of drawing, let's say this is what we call cutting. Cut and then fill, Start to start, by right, one arrow is coming out from, this is what we call start, and then this is also start. So start to start. So when you connect both activities together, the arrow that show relationship should have the tail and then arrowhead. This is what we call tail, this is tail, this is arrowhead. That should be the correct way, okay? To indicate where does that activity coming from, and then where does that activity goes in, okay? So in this situation, they are both arrowhead. So perhaps this activity could be connected from another activity, and then this drawing is accurate in such a way both activities start at the same time, okay? All right, finish to finish. So finish to finish, it looks like the same thing. Actually, it is the opposite. The starting of both activity, cutting and filling, we simply don't care. The most important thing is basically the finishing. Is again, when you draw this relationship, both relationship, let's say cut and fill. So the tail must be coming from cut and then goes into fill. So we indicate this thing as finish to finish. That should be the accurate way of drawing. But for this diagram, just simply want to indicate to us, maybe this activity later on will be connected into subsequent activities, okay? But two arrowhead is not correct, okay? Only one arrowhead, one tail, and then it goes into this one, and then arrowhead. This should be considered as finished, okay? So why do we want both activity to be completed concurrently or at the same time? Maybe it will be connected with the other activities, okay? That is the concept. And then start to finish relationship. This is a very special activity. If you do not know how to use, better not to use, because it is the reverse of finish to start relationship. Some people got confused how to use these activities, okay? For instance, we can use these activities with regard to, let's say, we want to construct a column, or brick wall. For sure, we need to lay the brick on the wall or that column, okay? So the start of laying brick, this is what we call start, okay? Can only, laying brick can only be started once you finish brick delivery. You see, you finish on brick delivery. Otherwise, you simply cannot start laying brick because there is no brick around. So similarly, the start of brick delivery must depend on the finish of the previous activity, which is, we call it procurement. Procurement is the purchasing process. Okay, so that is the relationship. And then again, the start of procurement can only be done when the sample is being approved by the consultant or by the architect. Okay, but the start of sample approve cannot be done without the finishing of the sample submission. That is the example. So normally, start to finish relationship is being used for procurement scheduling, or even for ISO, or what we call it quality control procedure. Example, another example, maybe you still cannot imagine. Example, we do have one what we call a river, and then we do have what we call old bridge. Old bridge. Okay, so the old bridge is being used until now. At the same time, they are constructing what we call new bridge. New bridge. new bridge. And for sure, in this construction, the old bridge will be demolished once the new bridge basically completed. With regard to the demolition, let's say demolition. Demolition considered as an activity. When can we start demolish? When can we start demolish the old building? Exactly when? For sure, when the new bridge is basically completed. When the construction of new bridge is completed. So you see, this relationship is like this. The start of demolition can only be commence, okay, begin when the new bridge construction already completed. That is an example of start to finish relationship. Okay, but it depends. Some people just simply use finish to start relationship with another concept. Okay, concept of what we call lag. All right, now let's give example of lag. How to use lag? Example, we do have two activities. Pour slab. Okay, let's say we want to do concreting on the flooring. So we pour in slab, okay, and then for sure we are going to continue with the second level of construction. In Malaysia, for instance, we do construct frame. Normally, when we finish doing the first floor, and then we will erect the column. Okay, we will put the rebar, the formwork, and then we will concrete the column. But of course, that column should be constructed on a very firm floor. Otherwise, everything will collapse. Okay, so you just simply cannot erect the column because you want to put your formwork, rebar, whatever, on a wet floor. So you must wait. This is what we call waiting period. Okay, waiting period for curing, for instance. Okay, curing or waiting for concrete to basically dry is not an activity by itself. Well, you can put that thing as an activity. Normally, people do not put because it just simply a waiting period. Even though workers can come in for a few hours to pour water to basically cover with a wet, what we call sheet or whatever, but that normally we do not consider that as an activity by itself. Okay, so we just want to let the concrete dry. So how do we put those things in scheduling? So we can use the concept of what we call lag. What is lag? Lag is something that we is similar to delay. We delay a little bit. What is basically the delay being referred to? We delay the starting of the following activity, the start of the following activity. Let's assume this one is basically 3 days. 3 days. So let's assume the pouring of a slab is basically normally take 1 day. 1 day only. And then the column erection will take around maybe 2 days. Okay, now if we do have lag, what would be the completion of the whole activity from pouring the slab and column? So from the calculation, so you just imagine this is 0, 0 plus 1 equivalent to 1. 1, now you need to plus with 3. 1 plus 3 equivalent to 4. 4 plus 2 equivalent to 6. You see, the whole process now completed in 6 days. Why? Because you indicate there is a waiting period. So this is how basically lag will influence the way we calculate our network diagram. Previously, we just simply add without the lag, Okay, let's assume there is no lag. Okay, there is no lag or nothing. We can draw something like this. This is 1 day, 1 day. This is 2 days. So the completion will take 0 plus 1 equivalent to 1. 1 is here, 1 plus 2 equivalent to 3. So without the lag, so we can complete in 3 days. But when we do have lag, so the way we indicate lag is like this, Fs plus 3. So the plus 1 indicate the starting of the column will be delayed by 3 days. We push back the starting of column by 3 days. At the end of the calculation, this will be different. So how to calculate? 1 plus 3 equivalent to 4. 4 plus 2 equivalent to 6. So now the timing of the early finish is equivalent to 6. Okay, that is what we call lag. Lag positive. Lag could be positive or could be negative. The negative one, sometimes people do not say lag. People say lead in order to differentiate between lag. This is what we call positive lag and basically negative lag. Some books, they use this terminology, lag or lead. So basically you understand everything basically refer to this concept. Positive delay of the start of activity, or basically lead is basically you push, you start a little bit earlier than what is supposed to be. Okay, let's assume another example. Lag with negative values. -2. Okay, so remember the word lag basically refer to this one. The start of the following activity, either it is being delayed a little bit or being pushed earlier. It start much earlier. Okay, let's assume two activity, site clearing and then cutting. Okay, cut and fill activity. Okay, site clearing normally involve the whole area of the project. Okay, the whole area of the project, sometimes very big. You don't have to wait for site clearing to completely finish in order to start the cutting, cut and fill. A certain portion of the area is already finished on site clearing, then at the same time you can do cut and fill. So you 2 days. 2 days meaning to say from this period, let's draw as if this is a bar chart in terms of time scale. This is what we call 2 days. You start this activity a little bit earlier than what is supposed to be. Let's say Fs without the delay. Normally you will draw something like this. Site clearing and then the following activity will start immediately. Imagine this is the time scale of the project. This is a time scale. Let's say activity site clearing is 4 days. 4 days. So 0 plus 4 equivalent to 4. 4 will be here immediately. Let's say activity cut is 2 days. 4 plus 2 equivalent to 6 days. You see, finish on 6 days. But when we do have what we call lead, how do we draw activity cut? Activity cut will be pushing a little bit ahead. Let's say the lead is 1 day, because we do have two here. Make it small. Okay, you see, just imagine we push a little bit ahead by 1 day, and how this thing will affect the calculation. You see, 0 plus 4 equivalent to 4. Now 4 is, we are going to minus with 1. So 3 will be here. 3 plus 2 equivalent to 5. We are going to complete the project in 5 days instead of 6 days. So this is how negative lag will influence the what we call project completion date. Okay, now finish on that thing. How about the application of lag into the start-to-start relationship? Okay, start-to-start. Labeling and plastering, if without the lag, so plastering will start here, exactly here. Just imagine this is the plastering. But now, because 5 days meaning to say here, we push a little bit like 5 days. So the plastering basically start a little bit delay from the original without the SS plus 5. Basically, plastering will start here, but now it is being pushed. Okay, so you have to imagine something like that. Otherwise, you cannot get the concept of lead and lag. Okay, just remember 5 days indicate here the start of the following activity. Okay, a little bit delay by 5 days. That is the concept. How about, let's imagine, if the plastering is going to be, we cannot use the word plastering because otherwise the logic might not be there. Okay, when you want to put certain relationship, both activity have to have some kind of logic. You cannot basically uh, plaster much earlier than the completion of laboring, which is impossible, isn't it? Okay, but just imagine this is activity A, this is activity B. What if start to start with negative? Let's say negative instead of 5, let's say -1. How do we draw this drawing? Well, without the delay, this activity will start here. Exactly the same as the A. But now, since we do have negative lag or start the following activity much earlier, so now this activity must be pushed as if it is 1 day ahead. So now this activity must start early. And that is the concept, okay, with negative lag. Okay, now finish to finish. Okay, finish to finish with 5 days lag. If without this thing, then this activity will complete at the same time. Here, this is the same time. But now, 5 days lag, we need to say positive 5. Positive 5. So the finish of this activity is now being delayed, being pushed back by 5 days. That is the concept. If, for instance, we change this thing into negative, let's say -2, so meaning to say the finish of this activity is much earlier. Let's draw this thing. Much earlier meaning to say here by 1 day. See, this is the negative. So how to read the lag or lead? The simplest way is basically the lag is basically being attached to the immediate predecessor activity. Okay, so either F or S, it doesn't matter. So that's how basically you play around. Okay, so just remember, positive indicate lag, meaning to say we delay a little bit in terms of either could be finishing or starting, whereas negative indicate lead, we advance a little bit in terms of finishing or starting of the following activity. Okay, depending on the type of relationship. Okay, those are the three extra type of the what we call relationship plus lead and lag. So that's what make the PDM diagram is much more what we call advanced compared to the original Aon diagram. Okay, terminology in critical path. Early start, early finish, late start, late finish. They are all equivalent or the same as what we already mentioned in AOA diagram. But in AOA or PDM diagram, the way we draw the diagram is like this. This like activity A, then you draw a few compartments. Let's say this activity B, you draw a few compartments. A do have early start of activity, then it will start on certain duration, and then it will complete on certain days. This is what we call early finish. So similarly, B will have early start, duration, and then early finish. Then later on, when we do the this is what we call forward pass calculation. Forward pass calculation, early start plus duration equivalent to early finish. Then when we do the backward pass, we call it backward pass. Late start, basically late finish minus duration. So late finish minus with D, then you get late start. So those values for each of the activity will be put inside the box. So you cannot miss any point compared to AOA diagram. AOA diagram, the issue is that the way the diagram is being drawn, some of the early start, early finish of what we call certain activities or each activity cannot be put inside the compartment available. Okay, so that's why we cannot see all the values. But for AON or PDM diagram, everything is inside the box. So everything is there. And then there is an empty box. We can put total float here. Total float, because at the end of the calculation, this can be considered as a complete calculation of values, but something is missing. What is the missing point? Is basically the free float, FF. So the free float, you can put it whenever you want. Example, if the box is still do have some empty space, so you just put inside the box. Okay, total float and free float. Okay, later on, we will show you example of this value, how they are being generated inside the diagram. And critical path, for sure, when total float is equivalent to 0, this indicate critical activities. When critical activities are interconnected, they are being called critical path. Remember, critical path is not singular. It could be multiple critical paths, except in our example, because our network diagram is so small, so the critical path is normally 1. Okay, don't get confused. Critical path could be multiple. Okay, forward pass method. Forward pass method is the calculation from the left to right. Okay, from the left of the diagram. Remember, we draw the diagram from the left and then goes into right, not the other way around. Okay, that is the concept. When you do forward pass, for sure, early start and early finish date will be determined. How to get the early finish date? Simple. Early start plus duration equivalent to early finish. When you do all the calculation from the left of the diagram until the right side of diagram, for sure you will get the overall duration. And you know what? You can get the value of free float already just by doing the forward pass method. Okay, you don't have to complete the overall calculation, meaning to say overall the calculation doing the backward pass. You can do that, but at the end of the day, you already figure out majority of the values: early start, early finish, free float, and then the overall duration. But then you can complete the backward pass method by calculating the late start and late finish. How to get the late start is simply late finish minus duration. You got those things. And then after you completed the late start and late finish, you can calculate total float, because the total float values can be determined from all the differences in terms of this value. Simple, total float is equivalent to late finish minus early finish values, or late start minus early start. This is the formula that you can use in PDM diagram, because in PDM diagram, all those values you can see easily. Okay, then for sure you can determine the critical path. Okay, example of network diagram. When you see something like this, meaning to say a box, this is the indicate node, and then the relationship, this is arrow indicate relationship. Automatically you know that this is what we call a AON diagram, or later on we call it PDM diagram. Okay, because the box is being shown in square, and then we do have arrow, but then the activity is inside the nodes. You see, you notice A is being written inside the nodes. This is what we call AON diagram, sorry. See, everything is inside the nodes. Okay, now let's give one simple example. Normally, if you want to draw a network diagram, you must have some what we call information. What could be the information? List of activity. In this case, we use start ABC, but in reality, you must put a proper name. Then there must be duration. Duration with unit. What unit you are going to use? The simple one could be days. And then the relationship between both activity, okay, immediate activities. We call it predecessor. Or instead of predecessor, you can use successor. But by default, in any computer programming, they normally use a predecessor, okay, by default. So it is not wrong that you use successor. For me, successor is much easier, but by default, it's like that. Okay, task number. Task number is what we call ID. In computer programming, such as Microsoft Project and Primavera, the computer ID will be auto-generated that reflect the name of the activity. Computer do not recognize activity by the name. Computer only recognize activity by the ID number. So that ID number is automatically generated. Okay, once we demonstrate Microsoft Project later on, perhaps you will notice that the ID will be generated. Okay, let's assume this is our project, simple project. We do have start, A, B, C, whatever. And how to draw a network diagram, PDM diagram or AON diagram. Simple. You start by looking at the list of activity and then draw box by box. Then you will connect them with predecessor. Okay, you notice that the start is the beginning of activity. It doesn't have any predecessor. This is what we call nil or none. So automatically you know that the start is the starting of activity. See the start here, because it doesn't have any predecessor. Then look at the activity after start. The predecessor start. So automatically you know that activity A and then E must be connected from start. So you notice activity A and E connected from. This is what we call connected from. You see, connected from. So that's how you put activity A and E. Some people might put A on the top and then E on the top and A at the bottom. Is it wrong or right? Actually, both way or any way that you draw, you put your box on paper basically is okay. The most important things, how do you link those activities together? If you wrongly link, then for sure you will get the wrong answer, regardless of how beautiful your drawing could be. When you put them into a wrong link, then you will not get the answer. So the link is very important. Where you put your box in terms of whether it is correct or not, accurate way of drawing, that could be subjective, because sometimes you never know how your drawing will look like until you complete it. Then you can revise and rearrange the box so that it will look nice. So what you have seen inside this diagram is the one that we already arranged in a very nice manners. Perhaps the first draft might not look like this, so it is okay. All right, then. So A and E already finished. How about B? Let's take a look at the activity B. B, the predecessor is A. You see, we already have the box of A. Then you draw one box of B. You simply connect the relationship from A, which basically indicate finish, to start relationship. When you do that, then people understand. Okay, so after we completed A, then B will start. Okay, after that. Then what else? Okay, how about C? C, activity coming from B. You see, B is already there. Then you draw C, and then you just connect with the arrow. Okay, the arrow doesn't matter. It is short or longer. It doesn't matter. It doesn't have any values. It just simply want to show the right relationship. Okay, what else? Just give one or two example. How about D then? D, there are two activities, C and H. Okay, C and H. So D, you can draw D first. It is coming from C, okay. And then it is coming from H. So you can draw H and then connect from that, okay. All right. Then, how about F? Coming from E. Okay, you already have E. Then you draw F. Then you connect from E. Okay. And then what else? G. Okay, it is connected from E. So you assume there is one activity, G. Then arrow is coming from here. Okay, now lastly, what? H. H from F and G. H, you already have H, but previously you didn't know how to connect, okay? So you connect from F and then from G. You see? Now you already completed the drawing. When you completed the drawing, always check again and again whether the relationship is correct or not, because once you draw the wrong relationship, then that is basically is useless. Okay, then you put the information such as the duration inside the box. Okay, inside the box. And then you make the compartment such as inside this drawing, they just show 4 compartment such as early start, early finish, late start, late finish, and then empty space there we can put total float and etc. Okay, now after you completed the box, then we are going to start doing the calculation inside the box. Okay, so remember, start is the milestone activity. Milestone, this one is also milestone. Milestone indicate important event with 0 duration, normally being used at the beginning or ending of network diagram only. Other than that, you don't need to use milestone diagram. So remember, milestone diagram also do have duration, which is 0 duration. So we start with zero calculation. We start with zero. We do not use one. No, no, no. One is only when you use in bar chart, then you can do that. But in Aon diagram, PDN diagram, you start with zero. Zero plus zero equivalent to zero. And that zero will be transferred, put inside this box and inside this box. So that's how we start with zero, actually. Okay, but it is understood. If, for instance, you do not draw a start and finish diagram, so still your diagram looks okay, nothing wrong. But if, for instance, you do have a lot of activities, it is always good to create one milestone activity such as start and then complete those things with finish, so that you can close the loop. Close the loop or pass, meaning to say we do not want to have the hanging what we call activities. So how to do the calculation? Again, very fast. 0 plus 7 equivalent to 7, because use this formula. Everything you add up. Then on B, remember the relationship is finished to start. So this numbering will be transferred to this box. 7 plus 6 equivalent to 13. Then this numbering 13 will transfer immediately, put into this box. 13 plus 3 equivalent to 16. Okay, now since you notice that there are two arrows going inside here and here, so they are basically criteria that we must take in terms of the values in order to put into this box. Okay, never mind, we go into E first. E, we start with 0. 0 plus 3 equivalent to 3. And you notice 3 will be here. And 3 will also be here because there are two arrows going in. So if it is for F, 3 plus 3 equivalent to 6. And then for G, 3 plus 2 equivalent to 5. You notice that there are two arrows going into a box. Meaning to say, between what we call F and G, which one is going to be used for H? Remember, H can only begin after F and G completed. G completed on the 5th day, whereas F completed on the 6th day. So F will take after whichever the longer what we call duration among the predecessor. So meaning to say 6 will go into this box. 6 plus 2 equivalent to 8. And now between C and H, there are two activity going into the D, but again, using the concept of when you do the forward pass, you take the bigger value, the biggest value, I would say, among predecessor in order to put into the successor or the following activities. So 16 is there, 16 plus 4 equivalent to 20. And you notice that this is what we call overall project duration. When you do forward pass calculation, for sure, you will identify early start and early finish date, and then the overall project duration plus the free float. You can identify the free float already from this diagram. How to identify free float? Okay, now I give you one simple formula. Free float is equivalent to early start minus early finish. But you must identify the predecessor and successor activity. For instance, okay, let's take a look at activity F. Okay, let's take a look at activity F. Activity F. Let's say we want to identify free float for activity F. In order, this is activity F. First, you must identify the following activity after F. What is the following activity after F? Which is basically H. So the early start refer to the following activity, which is H, whereas the early finish refer to the activity which we are calculating, which is F. So in this context, early start of H, which is equivalent to 6, whereas early finish of F equivalent to 6. 6 minus 6 equivalent to 0. You see, we can already know the free float for activity F. How about the free float for activity G? Now, focus on G. G. The following activity of G is basically H. Looks almost similar like as activity what we call F. So the calculation is like this: FF of G equivalent to early start of H minus early finish of G. Meaning to say, the early start of H equivalent to 6 minus early finish of G equivalent to 5, which is 1. So meaning to say, activity G do have free float equivalent to 1. Why? You just notice this numbering, 5 and 6. Activity G completed on the 5th day, whereas activity H, the subsequent activity, can only start on day 6. Meaning to say, activity G can be delayed. Can be delayed mean activity G does not need to start on day number 3. Activity G can start on day number 4. If it start on day number 4, then activity G will finish on day number 6. Still can catch up with the H, still can start on day number 6, which is equivalent to from activity F. So that is the concept. And we complete the calculation for backward pass. Okay, backward pass. What is backward pass? Is to do the calculation from backward. Remember, we already completed on this value 20. How do we do backward pass? Is basically this value 20, we just transfer inside here. Whatever the last value, we will transfer. And remember, the calculation is basically late start equivalent to late finish minus duration. So 20 minus 4 equivalent to 16. Then going back according to arrow, going back, okay, 16 will be put inside this box, 16 will be put inside this box, and then minus with duration to get this value. 16 minus 3 equivalent to 13, and then transfer inside here. 13 minus 6 equivalent to 7, transfer inside here. 7 minus 7 equivalent to 0. Okay, when we start with 0, and then we will go back into 0. And then how about H? 16 minus 2 equivalent to 14. But remember, 14 will go inside this box, 14, and it will go inside this box as well. So within the box, you just subtract with duration, you will get 14 minus 3 equivalent to 11, 14 minus 2 equivalent to 12. And then, now you notice that there are two arrows going back inside E. One is coming from F, one is coming from G. So in when you do backward pass, you will take the least value, least late finish value to late finish late start value to become the late finish value. We take the least value, which is 11, coming from this F, okay, activity, and then inside the box, 11 minus 3 equivalent to 8. And you notice that we start with 0, 0 plus 0 equivalent to 0. And you notice the 0 is from this box, 0 minus 0 equivalent to 0. You see, we start with 0, and then we should come back with 0. That is the concept of checking. Okay, lastly, total float. How to calculate total float? Total float, simple formula, equivalent to late finish minus early finish. See, The late finish value for D is here, this one. How about early start? Is here. You just differentiate between those value, then you already get the value of total float. Or late start minus early start. This one is not early start. Late finish is early finish, sorry. So the right side of the values, you differentiate, and the left side between the late start or early start value, it should give you, either one should give you the same total float value. So the total float value is 0, and you notice that when late finish and early finish, late start, late finish have equal value, for sure the total float is basically equivalent to 0. So in this situation for H, see, 16 minus 8 equivalent to 8, or 14 minus 6 equivalent to 8. 14 minus 6 equivalent to 8. 11 minus 3 equivalent to 8. 11 minus 3 equivalent to 8. 8 minus 0 equivalent to 8. 14 minus 5 equivalent to 9, or 12 minus 3 equivalent to 9. So you notice that the total value for the other paths basically do have values, meaning to say they are not critical, they can be delayed, but you must understand, in this diagram, there are 3 paths. One is here, this is the first path, then this is the second path, and this one is the third path. 3 paths. The total value, the total float values basically are being shared among the path. Let's say E, F, and G, E, F, and H, even though each of them do have 8 days as a total float, it does not mean that E can use all 8 days, and then F also can use 8 days, and then H also can use 8 days. No, no, no. They are being shared among them with regard to this line, this line. And the total value has something to do with the overall project completion date. Okay, so that's why the difference between total float, basically the value of delay with regard to overall project duration within the path, whereas the free float is only the free time of when certain activity have with regard to the following activity only. Okay, so that is the concept of free float and total float. So in my slide, normally if we do have the face-to-face class, normally I will ask students to go through this concept. So perhaps you can go back and try to draw a network diagram just by looking at this table. Okay, you should get something like this. This is the answer. Okay. Example number 2, if you go through, you should get the first, the most important thing is the drawing, and then try to do the forward pass and then backward pass. You should be able to get all these values, and then you should be able to also calculate total float and free float. Okay. All right. So one simple example. For instance, we start with 0. This is Aon diagram. Start with 0. 0 plus 2 equivalent to 2. 2 transfer here. 2 transfer here. 2 plus 6 equivalent to 8. 2 plus 3 equivalent to 5. 8 transfer here. 8 plus 6 equivalent to 14. 8 transfer here. 8 plus 1 equivalent to 9. Okay. Then there are 2 arrows here. Could be 9 or 5. So we choose 9. 9 plus 3 equivalent to 12. Okay. And then between 12 and 14, for sure, 14 will be here. 14 plus 2 equivalent to 16. Okay. So that is the answer. Then how to fill up the box? 16. 16 minus 2 equivalent to 14. Then 14 will be here. 14 will be here. So 14 minus 6 equivalent to 8. 14 minus 3 here for F equivalent to 11. And then 11 will be here. 11 will be here also. 11 minus 1 equivalent to 10. 11 minus 3 equivalent to 8. Okay. Then 10, you see, for B will be 8 or 10 equivalent to 8. 8 minus 6 equivalent to 2. Okay. And then between 2 and 8, 2 will be here. 2 minus 2 equivalent to 0. So that's how you basically calculate the values. And at the end of the day, you can calculate total float. See, total float is the value between the bottom values, left side and or right side, 0, 0, 0. So this indicate the critical path. The yellow one, the one that I highlight is basically, we call it critical path. Why? Because the total float 0. The rest basically do have values. Okay, so that's how you fill up all the values within the box. At the end of the day, you will answer this overall project duration, the critical path, and then subsequently you can know the impact of delay. Okay, for instance, you notice that activity D, F, and C do have what we call total float value. What happened? Okay, let's assume activity F. What happened if I delay activity F by 2 days? How to do that? Instead of 3, I just delay by 2 days, meaning to say I will take 5 days. So what would be the impact to the overall project duration? So you do the calculation back. 9 plus 5 equivalent to 14. So this is no longer 12. So you see 14, and this is also 14. So meaning to say, we already use up the total float up to the maximum allowable value. So it is still okay. The project will not be delayed. But what if instead of 2, now you delay, you put extra 1 more days? What would happen to the calculation? Yeah, you notice that this could be 6. 9 plus 5 equivalent to 15. And when this is 15, so this 15 will go inside here. So now the project will be delayed. And this activity now become critical. So now do you understand why do we need to calculate total float? Because we can see the impact of delay when that activity goes beyond whatever the allowable values being calculated here. But if we use computer will automatically will reflect the impact, but you must understand the fundamental. So this is what we are teaching, okay? In our first few classes, we want you to understand the fundamental first. Then when you use the software, automatically the software will give you all the indicator, such as certain activity will be delayed as a result of certain delay in time, okay, that you put as a revised plan or whatever. Okay. Okay, so that will be the end of the introduction. Let me stop the